So yesterday we were solving this equation. Uh, we got to this place where we used the log base 3 to get rid of that base 3 on the exponential, and that left us with x minus 6 is equal to log base 3 of 5/8, which is just that log base 3 of 5/8. Remember, is a decimal number. We're just going to get the exact solution and then the decimal approximation for that. So all we got to do is get that x by itself. So last step is add 6. That's going to give us log base 3, 5/8, and then plus 6. So there's our exact solution. We want to get the decimal approximation of that. So doing log base 3 of 5 divided by 8, and then outside the parentheses is plus 6, and should get 5 point. We're going 3 decimal places there, so 5.572. Good. A little problem there. Again, on this, so far we've only had a variable in the exponent on one side. We're about to see some that are, we've got variables in the exponent on both sides. So get that exponential isolated, and then we're using the log base of that exponential. So let's do a couple where we've got an exponential on both sides, which are the more difficult problems. So let's start with something like this. 5 to the x minus 2, and then 2 to the 3x plus 1, something like that. Okay. So when you look at this one, the key thing to notice is that you have exponentials on both sides, but you have different bases. So this is a different kind of problem than what we've seen so far. Because the bases are different, we can't just use log base 5, because that wouldn't do anything to the base 2 on the other side. We couldn't do log base 2 because that wouldn't do anything to the base 5 on the other side. So this is one of those where we're going to use common logs to help us solve that. And this particular author likes to use the natural log, which is what I'm going to use just because it's less writing. You could use the log base 10, but most folks you're going to see do this use the natural log to do this. So what we're going to do is we're going to take the natural log of both sides. Okay, so because the bases are different, that's why we're using that common log, that natural log. What that's going to let us do then is use the log property to bring that exponent down to the front of each of those. Okay, so that's going to be x minus 2 times the natural log of 5. This is going to be 3x plus 1 times the natural log of 2. Okay. So we're using that power property of logarithms to bring that down. Okay. The next step is to use that multiplication then to distribute this log base or natural log of 5 to that stuff, and distribute this natural log of 2 to that stuff. Okay, so natural log of 5 is a number, so we're just distributing a number. Natural log of 2 is a number, so on that right side we're just distributing a number. So that's going to be x natural log of 5 minus 2 natural log of 5. On the other side, we got 3x natural log of 2 plus 1 natural log of 2. Now, what that's going to let us do then is get like terms together. So like terms have to have the same variable, technically the same exponent on the variable. In this case, we're just looking to get the x stuff together and the stuff that doesn't have x together. So we need to get this guy and this guy on the same side. And then we need to get this guy, and this guy on the same side. Because the ones that are highlighted in blue, they don't have X's. So they're just regular numbers. So we're going to get those over here on the right. Things that are highlighted in yellow are X things. So we're going to get the variables over to the left side. Okay. So I'm going to do the math to get that to happen. So to move this -2 natural log of 5, I'm going to add 2 natural log of 5. Okay. To move this 3x natural log of 2, I'm going to subtract 3x natural log of 2. Okay. So that's going to cancel out. That's going to cancel out. And then on the left side, I've got x natural log of 5 minus 3x natural log of 2. On the right side, I have 1 natural log of 2 plus 2 natural log of 5. So this stuff over here is just, it's a number. It's an ugly decimal number, but right now we got it in its exact form. Now, here's the fancy part of this is when you look at these two pieces on the left side, they both have an x. What you can do is factor that x out so that you have x times the natural log of 5 minus 3 natural log of 2. And this is still equal to 1 natural log of 2 plus 2 natural log of 5.
Good morning, AHS. Please rise for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please remain standing for a moment of silence. Thank you, and now be seated. Have a wonderful day.
All right. So now what we've got here is we've got x times this stuff, and this stuff here is just a number. So it's x times a number. So to get x by itself, the opposite of multiplication is division. So I'm going to divide by that number. Natural log of 5 minus 3 natural log of 2. Over here, that's going to cancel out. That's going to leave us x. Over here, we've got this exact solution here. That's x by itself. That means we're done. Now we just need to get a decimal approximation for that. So if you got the TI-84, the fraction button is going to be your friend there. Okay, so I'm going to use the fraction button to help me separate that. So on the top part, I've got natural log of 2, 2 natural log of 5. So on my calculator, I'm putting in natural log of 2, close the parentheses, plus 2 natural log of 5. Make sure that's right. Yeah. And then on the bottom, I've got natural log of 5 minus 3 natural log of 2. I'm going to go down the bottom. I've got natural log of 5, parentheses, minus 3 natural log of 2. Make sure that's the right things. Yeah. Okay. Then I'm hitting enter. Negative 8.323. If you're not using the fraction button, you got to put the top in parentheses and do natural log of 2, close those parentheses, plus 2 natural log of 5. close the parentheses for the numerator, divided by parentheses for the denominator, natural log of 5 minus 3 natural log of 2, then close those parentheses. So you've got parentheses around the numerator, parentheses around the denominator. It gets you the same decimal out of that. The fraction button just makes it a little easier to read. Which it looks more like what's on your paper. Now, let's do another one of those. Those are the most difficult ones in this section. No question that they are more difficult. The clues that we look for is the beginning of the problem has different bases on each side with variables in the exponents. That's how we know it's going to be one of these types of problems, okay? So let's do us another one of those. I'm just going to make one up here. Let's do 6 to the 2x plus 3 equals 11 to the x minus 7. Making it up here. Okay. So when I look at that one, I see that the base of the left side is a 6. The base of the right side is an 11. Those are numbers that can't be rewritten as an exponential to get the base the same. So that's how I know, hey, this is one of those where I've got to use that natural log to solve it, because the bases are different on each side. So I'm going to take the natural log of each side. And I'm going to use the log property to bring that exponent down to the front. Taking the natural log of each side, and then that allows us to bring the exponents off of the exponents and put them down there in front as multipliers. Then what do I do with those natural logs that are there? What did I do on the last one? Distribute. That's the key here. Got to distribute this natural log of 6 to both of these pieces. Distribute this natural log of 11 to both of those pieces. 2x natural log of 6 plus 3 natural log of 6. X natural log of 11 minus 7 natural log of 11. So at that step, I've gotten everything into individual terms. Now I want to get like terms on each side. X stuff to one side, stuff that doesn't have X to the other side. That's the key to this. Okay, if you got to get the X stuff to one side, and the stuff that doesn't have X's to the other. So I like to move my X's to the left, just because that's where I usually want them when I'm solving. That's just what I do. So I'm going to move this X natural log of 11 by subtraction. I'm going to move this 3 natural log of 6 by subtraction over to the other side. That's going to cancel those things out. So on the left-hand side, all I've got is 2x natural log of 6 minus x natural log of 11. On the right-hand side, I have negative 7 natural log of 11 minus 3 natural log of 6. So the left side has x's, the right side does not. Now what? Yeah. So these two both have an x, so I'm going to factor it out. Right side doesn't change. So we factored the x out of both of those pieces so that I have 2 natural log of 6 minus natural log of 11. This stuff in the parentheses here is just a number. So I'm trying to get x by itself. So the last step to get the exact solution is to do what? Divide by that number. There's my x. -7 natural log of 11. 3 natural log of 6. There's my exact solution. Let's get a decimal approximation for that. We'll use the fraction button. Just helps me keep it organized. -7 natural log of something. 11 minus 3 natural log of 6. Close the parentheses, minus 3 natural log of 6. On the bottom, I have 2 natural log of 6 minus natural log of 11. 2 natural log of 6, close parentheses, minus natural log of 11. Enter. -18, go in 3 decimal places, be 0.691. Now, technically, you could solve every problem with these common logs, with the natural log, but it comes out a little quicker if you use the base of the exponential when you only have one exponential. If you got 2 exponentials, that's when you have to use that natural log idea. If you got just one exponential, use the log base, whatever the base of your exponential is. In this case, you got 2 different ones, so that's why you have to use that natural log. Those are as tough as they get. Kind of long, a lot of stuff, a lot of places that you can mistype something or miss a sign somewhere there. But that's as hard as they get. I mean, that's pretty difficult. Okay. All right, so practice problems on 463, 9 through 47. Then we skip a little bit and go to 61 through 109. Odds on those. Okay, so those are your practice problems for section 6.6. You got the rest of the time to do that and help you get a little practice and ready for a quiz tomorrow over 6.6.